Hey there, Emmanuel here from WebDevFuel, and in today's video we'll go over how to add background jobs with Go. And we'll also be using PostgreSQL for the database, since the package that we'll be using from the Go ecosystem uses that setup to be able to do background jobs. Before we go ahead and actually see how the code works and how to install the package and set up everything, we'll take a look at why choose Go when it comes to using background jobs, and we'll go over a few of the pros of doing it with Go. The first one is performance. In Go, we don't really need to think about memory management or low-level stuff when it comes to performance, and in the end, our program is going to be very much a performant program that runs very fast without us having to do anything extra like with other languages, for example C or Rust. And that is a very good use case for background jobs, since we want the background jobs to run as fast as possible, we want things to be snappy, and we want our jobs to run very fast without any kind of delays. Usually when we are doing background jobs, we want to do more important things inside our web applications, like sending emails, sending invoices, and those kinds of things. And we don't want to have delays in that part of our web application. We want those things to be snappy, and we should go with the Golang language to accomplish that. The second pro is that we want portability. We can compile Go to any kind of system that we want. So if you're running Go, for example, in macOS, like in my case, you can compile your program and you can send it to a Linux box, a Linux server, and you can run that compiled code without having to do anything extra, since Go provides us with all of the tools that we need to do cross-compilation. And the last pro is error handling. Now, in my opinion, this is the strongest point when it comes to Go for doing background jobs, since Go provides us with very nice error handling and it ensures that our program is correct. Go is very good when it comes to program correctness, and we are sure that at each point inside our code logic, we can handle the errors. We know where the errors are or might occur inside our web application, and we can handle them according to what our specific use case is, and that makes Go a very good use case for background jobs, since if a error occurs at any point inside our code, we can decide, for example, to retry the job, let's say, for example, 5 minutes later or 10 minutes later, and we can even set up different kinds of rules for the retry logic using the package that we'll be taking a look at in just a minute. But this is very nice when it comes to Go, again, because we can handle all of these errors. And for example, I've implemented background jobs recently in a project that I had to do. It was related to invoicing and sending invoices to customers, and I chose Go to do background jobs, since I was able to handle all of the errors. I can log all of the errors that occur inside those background jobs, and I'm assured that the jobs are going to work well each time that they run. Now let's take a look at the package that we'll be using from the Go ecosystem to accomplish all of this. The truth is that you can implement all of this functionality yourself, but it is going to be a lot of work, so it is preferable to pick a package that already has all of this functionality built in, and we can rely on all of this code to implement background jobs with Go. The package that I'm going to show you is the RiverQueue package, and you can take a look at it by going to riverqueue.com and taking a look at the website and the documentation yourself. And here, as you can see on the getting started page, here we can learn how to use or how to install rather River packages for Go, run migrations, which we'll be needing to do. So we'll be running the migrations with PostgreSQL, like this says, to get the River's database schema in place and create an initial worker and client to start inserting and working jobs. A few prerequisites here are that we need to have an existing PostgreSQL database, and it is most commonly used with PGX, which is a package that is essentially a driver for PostgreSQL in the Go ecosystem. So let's take a look here at the installation steps, and we want to run both of these. So we want to install first of all here the River package, and then also the River PGX v5 package. Let's first copy this, and inside the terminal, inside the root of the project, we want to paste this command to install this package. After doing this, we also want to install this other package. And after installing both of these, now the River queue is working inside our Go project. So let's, for example, add here simply a main.go. And we want to open this inside of, for example, NeoVim or your editor of choice. Here, let's navigate to the main.go file and we'll specify a package name, for example, main. And here, let's just add the main function. And for now, let's simply log a hello world message to the console to ensure that all of this is working correctly. So we'll say here log.println, and then we can say here hello world. But before we continue, if you want to learn more about how to build web applications with HTMX, Go, and PostgreSQL, then go to webdevfuel.com/hgsb or click the link in the description down below. After saving this, let's ensure that it is properly formatted, and then let's run here the program and see that it is working correctly. So we now have this log here that says hello world. So let's continue with the steps. The next one is to run the migration. So like this says, River persists the jobs to a Postgres database and needs a small set of tables created to insert jobs and also carry out the leader election, essentially to pick which jobs it should run at each point in time. Let's first of all copy this, and we'll want to install this globally. This is going to install the River CLI. So this is going to be an executable that is available globally inside our system. So after copying this, we want to paste this inside the terminal and run this command, and it is going to install the River CLI. After doing this, we will now have this River executable available to us. So if we say here River, as you'll be able to see, we have all of the commands that we can run, things like the bench command, completion, and we have all of these things to do the migration. So migrate down, get, list, up, and then also we have here commands to, in this case, validate the River schema. So now what we want to do is we want to run the migrate up command, and we will be needing to specify a database URL. So let's first of all ensure that we create a database inside PostgreSQL to be able to work with this example application. So let's say here PSQL, and then I'm going to enter here inside of the PostgreSQL shell using the Postgres database, which is the default one, and let's create here a new database, and we can call this one, for example, Go background jobs, so it stays consistent with the name here of the project. After doing this, we can exit the shell, and we need to export this environment variable, which is going to be database underscore URL. So let's say here the exact same thing, database URL, and then we want this to be the following thing, which is going to be essentially the connection string or URI to be able to connect to a PostgreSQL database. Now, this might be a bit different inside your system, but what we essentially want to do is we want to say here Postgres, and then we want to specify the username and also a password in case you have the need to be authenticated with a password inside your local system. And then we want to specify here the local host and then say what the port is. Usually PostgreSQL runs on port 5432. And finally, after doing this, after this final // we want to specify the PostgreSQL database name, and we want to specify the exact same one that we created here. And finally, we can now run the migration that will allow us to, again, add all of the tables, which will ensure that we can run River correctly. So let's copy here this command, and inside the terminal, we want to run this. And now if we take a look here at all of the migration, it creates first of all the River migration, then the initial schema, and then it does here a bunch more things when it comes to changing the schema. So these are essentially the changes that happen to the River package over time, and they sort of add each one of these changes as a new migration as time goes on. Now, after doing this, let's take a look here and see how we can run the jobs with arguments and also how to specify workers. So like this says, each kind of job in River requires two different types. So we'll have, first of all, the job args, which is a struct, and also a worker, and we pass here the type, which will be the args. So like this says, the job args struct has two purposes. First of all, it defines the structured arguments for your worker. These arguments are serialized to JSON. So in order to be able to grab information or to be able to have a set of arguments that we pass to a job, they always have to be serialized, since we want to send that to the database in a JSON format. And like this says before, the job is stored in the database. So to be able again to store this in the database, it has to be in a JSON format. And it also defines a kind string method that will be used to uniquely identify the kind of job in the database. So it is also going to grab this string. So this is a method that is attached here to the job args that then sends to the database the information about the kind of job that this job args here is related to. And as an example, they provide us here with the sort args. So this will be sort of a job that is going to sort the arguments that we send over in a JSON format. So let's copy this thing here and let's paste this inside our code editor. So for example, we can add this to the main.go file. Now in an actual project, if you were to implement this, you would probably want to place this in a different package. But now to keep things simple, let's just add all of these things to the main.go file. So we have here the sort args, and this is a struct. And then this has here the arguments inside of it. We have the strings that we want to sort. And then we specify, like with any other Golang struct, the type. So this is a slice of strings. And then we specify here the key, the JSON key, which is going to be strings, all lowercase. And finally, we want to add here the method that will specify the kind of job that is running. This returns a string, and then it is going to return this string that says sort. After doing this, we want to add now a worker. So this is going to be a struct. And inside of this, like the documentation says, we want to embed the worker defaults. And by using Go generics, we want to pass this type into it in the following way. So we want to add here the type, which is going to be the sort args in this case, or the any other, let's say, job args that you create. So let's copy both of these things, and then we'll also take a look here at the function inside the code editor. After saving this, it is going to import here the River package. And again, we have first this struct, which is the sort worker. And then we want to add the following things here. We want to add a function, and we want to pass here the sort worker, and it needs to be a pointer to the sort worker or to any other, again, worker struct that you might have. And we say here that this variable name is dub. And then we want to attach to it a method that is called work. And this method will take two different arguments. First of all, a context, and this will allow us to do things like canceling all jobs that are running inside of a context, and it keeps track of all of the jobs, again, inside a particular context. And it will also allow us to do things like, let's say, pass different kinds of, for example, connections to different clients that we might have. So like I said at the beginning of the video, I have a use case for this that is currently running in production. And in my case, I want to be able to connect to different clients, in this case to different APIs, to be able to then hit those APIs and do different kinds of things inside of the worker when the worker is running. And to be able to do this, I simply attach, for example, a key to this context. So I would do something like, for example, context equals, and then I would say, for example, context with value, and we can pass here the context that we want to add the value to. Then we could add here, for example, the key, so something like API X or Y, for example, and then we pass the value, which would be, for example, the pointer to the API client. and then we can grab that API client here by reference inside of the worker. So after passing here the context, we also want to pass as an argument the job, and this is going to be a pointer to river.job. And again, using here Go generics, we want to add here the sort arguments or sort args, the struct, here inside of this. The function here that we attach to the sort worker will be returning an error, a possible error. And then inside of this, we want to run the job. So as you can see, we want to use here the sort package from the Go standard library. And then we'll be sorting here the strings. We pass here the strings that we want to sort, and we grab those from the job. So in order to access all of the arguments of a job, as you can see, we first say here job and then args, and then we have access to them. So if we say something like here job and then args, as you can see, args are the argument of the job. And then after we do this, we can not only access here the kind, so this is the method that will be returning here the string, but also the strings which is included here inside of this struct. So this will be running this here inside of the function, and then it is going to simply print this to the console and print here a very simple message that says sorted strings, and then we pass here the strings that were sorted and we return nil. And by returning nil, we essentially tell here the river package that this job was successfully done, and we can also return here an error. In case we return an error, then the error is going to be placed inside of the database, so we can keep track of the different errors that occurred in order to be able to then take a look at the jobs that are currently inside the database and debug things and see what happened with those jobs, and let's say, for example, manually retry them, or they are going to be keeping on retrying until a certain point, and if we choose to do so, we can extract that information and try to manually reinsert those jobs back into the database so they try to run again, so that things go well in that situation. And the cool thing about River is that it also provides us with different methods that we can return from this function to sort of interact with the jobs. So let's say that we, for example, want to snooze this job. Let's imagine, for example, that you want to run a job, but you want to wait for something else to happen. And you run your job, and it is not actually an error that occurred, but rather you want to wait just a little bit for the job to run. So let's say in the case of the invoices, that you are still waiting for a customer to be created inside of a different API, and you want to snooze the job and wait just a little bit more until the client, or the customer in this case, is created. In that case, we could do something like river.job snooze, if I'm not mistaken, and like the method says here, job snooze can be returned from a worker's work method to cause the job to be tried again after the specified duration. So this is not in fact an error, but just snoozing the job and doing it later. And by doing this, we essentially tell here the worker that we want to try this later. So again, keep in mind the River package has all of this functionality, again, built in for us to interact with it and do cool things when it comes to running background jobs using Go. Now let's take a look at how we can register workers, and essentially here what we want to accomplish now is initialize a River client after doing this, and be able to pass into it multiple different workers that we can use to run jobs in the background. So like the documentation says, jobs are uniquely identified by their kind strings, and workers are registered on startup, so when we start our program or our web server, so that River knows how to assign jobs to a worker. So as you can see, we say here workers, then we initialize here the new workers, and after that, to add workers, we use this method, and it is going to panic if the worker is already registered or invalid. So keep in mind again that we want the workers to be initialized when the program starts, And if something goes wrong, we don't want to even start the server, because we want all of these things to be working correctly when it comes to the background jobs. So let's copy here this code snippet, and we want to add this here to the main function. We'll also delete here this hello world log. And after doing this, we want to pass here the following thing. So we want to say here add workers, add worker rather, and then we want to pass two different arguments. We'll be passing as the first argument here the workers, which is a pointer to river.workers. And then we want to pass here the worker that we want to add as a reference. So we pass here the ampersand, and then we pass here the worker struct that we've initialized down here. After doing this, like it says, add worker panics if in case of an invalid configuration, but we can also do it safely, and it is going to return an error if we use this method. So we can use this method, which is going to panic the program. I usually just take this approach since it is simpler, and again, I usually want the workers to actually be correctly initialized before the web server actually starts. But you can also do this thing here, which is going to return an error. Now we get to the part of the client. So like the documentation also says, a River client provides us with an interface for job insertion and manages job processing and maintenance services. A client is created with a database pool, driver, and config struct containing a workers bundle and other settings. And here's a client working one queue, the default one, with up to 100 worker go routines at a time. So it is going to initialize here a new queue that is called default, and it is going to have 100 worker go routines at one time. So we want to first of all initialize here the connection to the database, and actually I think we can copy all of this at once. And let's take a look here at this inside the code editor. So let's see here, we have the context. Let's say that, for example, the context can be context at background. So we can say something like this. And then we can say here, colon equals, and grab here the context from the background. And now with the context initialized, we can pass it here into this function. So to be able to initialize the database connection, we say here pgx pool.new, we pass the context and also the environment variable, or the string that is going to allow us to connect the PostgreSQL database. In this case, we extract it from the environment variables, and then we handle the error here. For now, we can leave this as is, and later we can add something here like a very simple log message that lets us know that something bad happened here. After doing this, we want to initialize the actual client. So we say here river.newClient. We pass here the connection to the database by saying river pgx-v5.new. So this is the package that we've installed previously. And then we say here, we pass here as an argument a DB pool. So this is the pool that we've initialized here. And then the second argument is going to be the river config. So if we take a look here at the documentation, we have two arguments, the driver and the config, and this is the second argument. We need to pass this as a reference, river.config, and then we specify here the queues and the workers. The queues are going to be very simple. We want to pass here a map where the keys are strings, and the values are river.queueconfig. So in this case, we have this thing that is imported from the river package, and this is an alias to this string that is default, so the default string, and the value is going to be a queueconfig, and it is going to allow us to pass here the max number of workers. So here we pass 100, and then we specify the workers that we've initialized up here. In this case, we only have one, the sort workers. So after doing all of this, we handle here the error, and then we run the client like this says in line, and all of the executed jobs will inherit from the context. So we say here if error, and then we start the river client, and we pass as an argument the context. Again, keep in mind in this case, since we are running inside the main function, we'll be passing the background context. And then we also have a way to stop the river client from working. Like this says, the client should also be stopped on program shutdown. And we also have here something more intricate, something a bit more complex when it comes to doing graceful shutdown, but we are going to skip over that part since it is a bit more complex and we want to focus sort of on the basics on the basic functionalities of the River package. In our case, to keep things simple, let's just copy this code snippet, and inside the code editor, after initializing the River client and ensuring we don't have any kind of errors, let's just say here defer, and then we pass here a function, and we also need to call this after this, and we can add this part. So we want to essentially defer this, and when the program stops working, we want to also stop all we want to rather stop the River client from running. And we are going to leave all of this error handling as is. Again, if you want, we can add here logs to be able to see what's happening, but to keep things simple, we're going to leave this as is. And then we have here also more information when it comes to insert only clients. Like this says, a common pattern is to have front-end processes which only insert jobs but do not work them. But we are going to leave again all of these details for later. Now we are interested in the part that allows us to insert different jobs into the database. So like you can see here, we have a way to insert jobs into the database by using the River client. So after we initialize the client, we have this method insert_tx, which is going to insert a job using a transaction. And we also have a way to insert a job without using a transaction. Now, the reason for using a transaction to be able to insert a job is because in a lot of cases with web applications, we actually want to be able to insert a job only if a certain thing is done inside of the web application. So let's take the example of registering a user. And I also think that this example is somewhere here inside of the RiverQueue documentation. I remember reading this a while ago, but I'm going to just try and explain to you this concept. So let's say again that we are trying to register a new user inside of a web application. So the user goes to your page, they insert an email and a password, and then you want to do background jobs related to that registering of a new user. So let's say that you want to send a new email, or you want to add them to a different system, for example, a CRM, or things like that. In those cases, you want to ensure that the user actually gets created, and you don't want to, for example, let's say send an email to a user if an error occurred while trying to register. So let's say that someone, for example, inserts an email address that already exists. Again, you want to ensure that you only send the email if the user was actually created. And if the error that occurs when trying to insert a user is at the database level, then you want to sort of wrap all of these things around a transaction to ensure that the user is actually created, and then the job inside the database is also created. And if there's some kind of error with creating the job, we don't want to create the user, and vice versa. If there's some kind of error when we are trying to create the user, then we also don't want to create a job. This is sort of a one-shot action, so we want to do one thing as a whole. So we want to create the user, and creating the user means all of these things. It means creating the user inside the database, sending the email to the user, or in this case, enqueuing this job into the queue to be able to send it. Then if an error occurs, that's something separate, but we want to ensure that all of this happens sort of at once. And for that to be able to be done, we use here this method insert_tx. Now for our use case, even if I explain all of these things to you, in our use case, we are not really interested in doing this inside of a transaction, so we'll be using this simpler method. So let's say here that we want to copy, in this case, this code snippet, and we'll be adding this here inside of our main function, and we'll be essentially sorting these three different strings, so whale, tiger, and bear. So now we have everything that we need to be able to insert jobs into the database and run those jobs in the background. We also have here a bunch of different sections when it comes to the River Queue package, and I encourage you to go here to the documentation. I'm going to leave also a link in the description down below, so you can take a look at all of this. And also make sure that you go here to the GitHub repo and you leave here a star, so that you give here props to this project, which is an amazing project that allows us to do amazing stuff with Go and background jobs. We also have here a way of inserting jobs in a batch in case we want to insert a bunch of jobs. But now with all of these set up, let's take a look and see how this works. Here inside the terminal, we want to simply run here this. And before I actually do this, I'm going to open the connection to the PostgreSQL database and take a look and see how the schema is currently, and then we'll compare and see how these jobs are added to the PostgreSQL database. But before we continue, if you want to learn more about how to build web applications with HTMX, Go, and PostgreSQL, then go to webdevfuel.com/hgsb or click the link in the description down below. So I went ahead and connected to the Go background jobs PostgreSQL database. And here inside the schemas and inside the public schema, we now have here three different tables. We have the River client, the River client queue, and then we have this River job, the leader, the migration, and also the queue. And now, while connected to the database, if we say here, for example, select star from River job, we'll be able to see that at the moment we don't have any jobs here inserted inside of the database, and we have here a bunch of different columns. We have the state of the job, we have the attempt, we have the max number of attempts, so this is going to keep track of the current attempt, then this is going to keep track of the max number of attempts, and also, for example, if we snooze a job, it is going to increase the max number of attempts, so it is going to snooze the job for later, and it is going to increase the max number of attempts. And then we also have here attempted at, then created at, finalized at, and this went way too far. So let's go back here. Then we have finalized at, and if we continue scrolling here, we have scheduled at, and we also have here the priority of this current job. And then we also have the arguments. So this is the arguments that we pass again in a JSON format. We have here attempted by, so attempted by the client that is currently running inside of the system. Then we also have the errors. So if we return any kind of error, it is going to be stored here inside of the database. So again, we can take a look at the errors and see what's happening. Then we have here the kind, the metadata, the queue, then the tags. We can also have different kind of tags to each one of the jobs. Then we have the unique key, and finally the unique states. So we have here a bunch of different information, and again, we don't really need to think much about this. It is going to be used internally by the River package, but it is still important for us to understand what's happening here and what all of these columns are doing. Again, in my system that I'm currently running using this package, I usually have to take a look at the database and see what's happening in case there's any kind of error. The cool thing about, again, Go is that usually there are no errors occurring inside of the system, but still, again, it is very important for us to still understand the packages that we are using, even though they are created by someone else. And now if we run the Go program, it is going to run the job, and it is going to stop right away, since we don't have any kind of thing inside the Go program that is keeping it running for longer. We're going to take care of that in just a second. We'll be adding an HTTP server, a very basic HTTP server that will allow us to not only run this program for longer, but also send HTTP requests to our server that is then going to run background jobs using the River package. For now, let's see how this works. So if we run the Go program here, as you can see, it prints to the console the sorted strings, so bear, tiger, and whale. And now if we also take a look again here at the PostgreSQL database and we run this query again, as you can see, we now have here a new job with the state of completed. one attempt and also the max number of attempts. In this case, River by default adds a max number of attempts of 25, and we can also configure River. We have information inside the documentation on how to increase this max number of attempts, but by default 25 is a good number. And then we have here information about the time when things happened. Again, very important to keep in mind. We have here the timestamp of when this was attempted, when it was created, so when the job was inserted into the database. Then we have here the finalized at, so this is when the job was finalized. So either if this continues running with errors until the 25th attempt or when it is successful. Then we have scheduled at, which is essentially the next retry of this job. So it is going to be retrying at this timestamp. In this case, again, since the job is already completed successfully, it is not going to run again. Then we have here the priority, it is number 1. And then we have, again here, the arguments. So if you take a look at this, we have here the strings, which are whale, tiger, and bear. So this is, again, in JSON format. Then we have here the attempted by. Again, this is the client. This is the host name of my laptop here, my local system. And then we have the errors. We don't have any kind of errors. We have the kind, which is sort. Again, we have that method that is going to return the kind. And then we have the metadata, the queue, which is default, and then the tags, we haven't specified any, and both of these things are empty by default, since we don't have any kind of uniqueness when it comes to this job. One of also the cool things about River is that it provides us with a way to have unique jobs by key. So in case that you want to have a unique job by a specific logic happening inside of your web application, let's say, for example, so let's say that you, for example, don't want to have a confirmation email after the registration being sent to the same email address twice. You can ensure, let's say, for example, in that case, that it is only sent to one email address. And in that case, you can have a unique job by the key. So after doing this, we are now ready to add a HTTP server, something again very basic, to our web application here. So we can actually turn this into a very simple Go program into a web application. So after doing all of this, we are going to initialize here a new client. And to accomplish this, we'll be using the She router. So let's take a look at the documentation and see how we can install it to add here an HTTP server to the Go program. This is my favorite router inside of the Go ecosystem, the She router, and to install it, you simply need to search for it inside of Google. It is going to take you to the documentation. And to install it, we have here the instructions. So we want to copy, first of all, the command. So to install it, we want to copy this command, and then inside the root of the project, we want to paste this here, and now it is installed. And after doing this, let's navigate back to the main.go file. And here at the bottom, we can add this. So let's simply initialize here a new router after doing all of this. And we can still keep this thing here to insert the job on, or we can actually just comment it out. And then we'll be adding this later back into the code inside of this handler. So we have here this new router function that is going to initialize a new router. Then we want to add a very simple middleware, a logger. And then when we hit this endpoint, we want to print this thing here. Let's also ensure that this only runs on localhost. And after saving this, we can go back here. And now if we try to run this, we are going to see this error, and that's actually because we have an error when it comes to the import. So we want to always ensure that we are importing from the correct version. So we want to say here v5, both on the She package itself and also on the middleware. And after doing this, we can run this again. And now the HTTP server is running in the background. And this means that not only we have an HTTP server working, but now our background jobs also stay running for longer up until the point that we stop the program. So now if I do something like this, and I say here curl and then localhost port 3000, we are going to see this welcome message, meaning that the server is working in fact correctly. So now let's add the job here. So we want to insert a new job inside of the database, meaning that it is not only going to be inserted, but also be run by the package automatically. So if we now, instead of saying this, we add this thing here. Now the Go program has to be restarted. So let's stop the HTTP server. Let's restart it again. And after doing this, now let's go back here to the database. So again, keep in mind that at the moment we only have one job, the job that was ran when we ran the program a few minutes earlier. And now if we try to say here curl localhost again, it is going to not only print here to the console the HTTP request that occurred, but also the job that was run in the background. And we can continue doing this multiple times, and it is going to continue running new background jobs using the River package. So now if we select here the River job table again, it is going to show us here all of the jobs that were run successfully. Again, as you can see, it is pretty simple to run background jobs using Golang and this very cool package that is called RiverQ, and it provides us with all of these cool things that allows us to insert jobs into a database and run them in a very performant way, not only because of how well this River package is written, and I really like this package for running background jobs. I would say it is my favorite package for background jobs from all of the ecosystems, and I've tried a lot of them. I've tried also Oban from the Elixir ecosystem, which I think is very much on par here with this package. I've tried packages from the Rails ecosystem, from Laravel, from all of those different ecosystems. I've tried them, and this is my favorite because, again, not only how well this package is built, but also because of how Go works when it comes to error handling, which again, at the beginning of the video, I said that it is the strongest pro when it comes to doing background jobs with Go, since we can know at each point of our program if something might return an error, and we can handle it in a way that makes sense for us inside of our web application. It sometimes means deleting a job, sometimes it means snoozing a job, sometimes it might mean just returning back the error itself. But the cool thing is that we can, at each point of our program, know exactly what's happening and return an error. Again, I want to encourage you to take a look here at the documentation because this provides us with a lot of different cool functionality. We have here a way of canceling jobs. We have a way to pause queues. Let's say that at a particular moment you want to pause an entire queue from running. In cases, for example, where you might have an error that's occurring multiple times and you don't really know why that is, you can pause the queue, still have the ability to insert jobs into that queue, insert things into the database, but pause it for a little while, then you resume it, and after resuming it, then things are going to continue running correctly. We also have here the ability to do periodic and cron jobs, very cool stuff. And again, a bunch of different functionality that River provides us with. And if you also want to give here your support to the package, you can also use the Pro version, which provides us with a bit more functionality that we can use in more advanced web applications. And it is also a very cool way, besides giving a star to the package and to this entire project in GitHub, it is a very cool way of supporting this project if the things that you are doing in your web application are a bit more, let's say, large scale, and you can afford to do so. So with this being said, again, this is how we run background jobs with Go. I hope this video was helpful to you, and I'll see you on the next one.